So now we are going to represent the molecules in Fischer representation. So what we have to do in Fischer representation? In Fischer representation, we have to do a 2D representation of 3D molecules. We all know that in nature, in environment, all the molecule exist in the form of 3-dimensional, because all molecule exist in nature in 3-dimensional, but we have to represent that 3D molecule in 2D format. So in that particular case, we have to use the Fischer representation. It's a very important representation in organic chemistry that you have to consider. So 2D representation of 3D molecules you have to consider. In this particular representation, again we have to use sp3 hybridized carbon atom. Sometimes we are going to use sp2 hybridized carbon atom. I am let you know, like when we are going to use the sp2 hybridized carbon atoms, that particular position always occupied by the most oxidized group. You have to remember this by heart. In Fischer representation, the most oxidized group come on this particular position, on this particular, in this particular vertical, topmost vertical position, the most oxidized group have to come on this particular place at anyhow. So in the Fischer representation, the 2D representation of 3D molecule is going to happen. And when the Fischer representation, the 2D representation of 3D molecule is going to happen, then we have to consider, first point is that the carbon must be sp3 hybridized, but generally I am saying this, but some cases we have sp2 hybridized carbon atom in Fischer representation. That I will explain you how this can be possible, because this can only be possible when we have an oxidized group in double bond forms, like CHO, that is C double bond OH, it's aldehyde group. That particular aldehyde group is the oxidized group, so that particular group have to become on the topmost vertical position. So first point is that we have to consider sp3 hybridized carbon, and the most oxidized group have to come on the topmost vertical position at anyhow. Next what we have to consider is this particular representation. In this particular representation, this is the vertical line, this is the vertical line, and this is the horizontal line. So horizontal line usually represents the above thing, because it means that this particular substituent, that is the substituent R1 and R2, is coming towards us, which is present on the horizontal line. This particular horizontal line represents the above the plane stereo. In this particular above the plane stereo, it means that the R1 and R2 substituent is coming towards me, because I am the observer, so it's coming towards me. And the particular R3 and R4, if I am talking about R3 and R4, then these two substituents are going far below from the particular plane. So from a particular, this particular carbon is in the plane, this particular carbon atom is in the plane, and these two substituents R1 and R2, the two substituent R1 and R2 is present above the plane. It means it's coming towards us, coming towards the observer, and the substituents R3 and R4 is far below from the observer. It means that the substituents R3 and R4 is moving away from the observer. It means that it's moving away from the observer. So these are the characteristic Fischer representation that you have to remember. The horizontal line is going to represent the above the plane criteria. It means that these two atoms are present above the plane, and the vertical line is representing the below the plane criteria. Always remember that in later lecture we have to learn about RNA's configuration as well. So in that particular configuration, the Fischer representation plays a very important role. So you have to understand the Fischer representation